Record. Sure. All right, here we go. Any questions on the homework? Oh, here we don't go. I forgot to take attendance. Now we're ready. Okay. I remember I left off that last portion. I said I would do it today. We'll do that one today as well. All right. Hey, last lesson of the semester. It's both a good news, bad news story. It kind of stops the chapter at a point where it's kind of like dead smack in the middle, right? So we'll pick this up after Christmas. We will have a chapter 6 test at the end, but it'll be after Christmas. I will have up through 6.3b on the semester final. All right, homework tonight. Question. Okay, so here's my advice to you. Doesn't have to be today, but it would be nice if it was today. I need you to start putting together a resource card, whole sheet of paper, right? Now, like I said, this kind of breaks between us and after Christmas. So this will be continued after Christmas, but you're going to need to have one sheet of paper that has nothing but trig identities and functions written on them. We already know 18 of them right now. I'll show the 18 that we know, but this list grows. I've never actually counted, but I'm guessing it's over 50 of these that we'll have written down. So if you start a resource card early, right? Most people can fit all the trig functions on one sheet of paper, front and back, right? But if you start it early, then you're not up next to a test day. Like, oh, I got to write down all 50 trig functions and identity on a resource card, and it turns into you're up till 2 o'clock in the morning type thing. So if you start a resource card now, right? I'm saying take what we do today and just start working on a resource card. You can have your normal 2 sheets of paper, and you can have a unit circle and trig identity sheet. So that's 4 on every test that involves trig, right? All right. I'll come back to it at the end. All right. So this continues, and it will continue for the rest of the chapter. Every day we're gonna get more of these things called trig functions or trig identities. All right. So that long list of trig functions that are in the back of the book, we just slowly start eating away at it, one at a time, one at a time, one at a time. So far, 18 of them. These trig functions are also called trig identities. Trig identities, trig functions, we use them interchangeably, right? So why do we need these trig identities? This is the worst answer ever in a math class. You just got to trust me that this become more important to you as you go up levels of math. Next year in calculus, you use these all the time, very frequently. These things called trig identities or trig functions. It makes the math easier. It's just in pre-calc, we don't get to see that. We just get to do these things with trig functions. We don't actually use it to make our life easier. We just do it's seemingly strange stuff. Remember when the first time you learned fractions, and you're doing fractions for the sake of fractions. You don't really do anything with them. And eventually you get to use the fractions to solve problems. But we don't get past that stage in pre-calc. We just simply learn the trig identities and we kind of simplify expressions with them. So it's kind of like the first time you're taught the quadratic formula. Okay, great. I can do this thing called the quadratic formula. Why am I doing this? And then eventually you see the reason why you do it. All right. We're going to spend a lot of time. These are prisoners cutting grass, right? It's going to feel like you're a prisoner because there's lots of them. Right? I've never counted, but like I said, it's about 50 of them. You're going to learn trig identity after trig identity after trig identity. And you're like, why am I learning all this stuff? Eventually, calculus for next year, it will pay off. All right, so we're going to begin our journey, refreshing our memories for the 18 that we already know, right? So the 18 things that we already know are called trig functions or trig identities, about one. So if you are a trig identity, well, you are an equality that has one of the sine, cosine, tangent, cosecant, secant, cotangent in them. So you are a trig identity. If you got an equal sign and you got the word sine, cosine, tangent, cosecant, secant, or cotangent in them. And we know 18 of these so far. So we're well on our way to that 50 or so trig identities that we need to learn. What? I put one on your desk. Then Seth stole it. Then Abby stole it. Oh, the look on her face. Yes, she stole it.
Because you didn't give me one.
Sorry.
You gave Ish one, but not me.
You trying to say I'm playing favorites?
Yes.
Okay. I didn't give Evelyn one either.
Because she's not here. So you said when you walked in here, you said write all of the traits.
Yeah, so there's going to be so many of these, like you can't memorize them. So you need them on a resource card. So I'm just saying, I'm going to give you, I forget how many I'm giving you today, 11, 14, something like that today. So you just need to start making a resource card. Basically, you're going to take the back portion of the book and copy it down. Every one of those.
And that's just on a whole different page. And
Whole
we're allowed to
different,
use that.
separate from the normal two and the unit circle.
We're allowed to use it.
Yes. When you take the SAT, there are no trig identities other than SOHCAHTOA. We're getting 11 or maybe 14. We'll count. Let's count. We do. Amazing. All right. Well, right. You already know 18 of them. Here's the 18 that you know. Well, you know sine, cosine, tangent, cosecant, secant, cotangent, the normal SOHCAHTOA ones, right? That's 6. And then you know the ones that involve. That's the second
The
one.
ones that are
The unit circle ones, right? The unit circle ones, right? Sine theta or sine t is equal to sine y, right? So you know all of these 6. Well, 6 and 6 is 12. And then lastly, we know the ones involving r. Those are the non-unit circle ones. Now, okay, maybe it's a little game here. They're all SOHCAHTOA basically, but it's an understanding of, are you on a unit circle, not on a unit circle? Are you just a triangle floating in space? If you're a triangle floating in space, SOHCAHTOA. If you're a triangle on a unit circle, then it's these 6. And if you're a triangle not on a unit circle, but on the coordinate plane, then you have that r involved. So yeah, it really is 18 of these. Okay. Okay, we use these over. I will use them many times today, all 18 of these today. All right, the but here is that there's more. There's more, and there's more, and there's more, and there's more. Boy, are there more. This is not me, but this is some, I Googled on, I said, hey, give me a resource card for pre-calc, and this is what popped up. And so some pre-calc teacher made this up. I don't know who made it up, but it becomes so overwhelming that look what the teacher did, right? The teacher said, hey, if you feel overwhelmed, take a moment to enjoy this pig with a flower. Like, this is typically where the tiers come involved with pre-calculus and trig. It's because this is crazy overwhelming stuff, right? So just recognize for yourself that eventually you will be a little bit overwhelmed with this. If you're always overwhelmed, well, then you're going to be doubly overwhelmed, right? But most students are a little bit overwhelmed with trig stuff. Okay, so always remember the pig with the flower. What?
Have you had anyone actually cry?
Every year, right? Frustration. I've never had too many boys cry. Usually it's girls, but I've had a boy cry before. Like they think, oh, I'm good at math. Why can't I get this stuff, right? All right, so here we go. Yes, I got to prove all these. These are quickly proven. All right. Hey, true or false? Yeah, this is one of the 18 that we already know, right? Okay, so that is true and that is true, right? Okay. Well, what if I rewrote the cosecant a different way? I'm just going to do a little bit of algebra. Instead of writing it as hypotenuse over opposite, I'm going to write it as 1 over, well, if I write it as 1 over this, it can't be like this. I would have to flip it. So if you did a copy dot flip, it would turn back into the original cosecant. Do you see what I did? I just took the hypotenuse over opposite, flipped it, put over 1. So if I were to do a copy dot flip, I'd get right back to where I started from. Yes? Anybody see it? Anybody see it? This
Isn't that what
is that. But that is, what the heck?
Oh, no
The
math for us
projector's
today.
broken, no more math.
Oh, darn.
This, sorry, Evelyn, you can't see what I'm pointing to. This is that, but that is that. So what can I write here? Yeah, you got it. Those two things are the same thing, so I can do a substitution, and instead of writing that fraction, I can write the word sine. Yay, there's a new one. There's your next trig identity.
Yeah, calculator.
I know. It's a trig identity all by itself.
We already made it.
Oh, it's visibly different, but yes, it is. But this is a trig identity. All right.
But it means the same thing.
Well, it doesn't mean literally the same thing as this. This says use the hypotenuse of the opposite. This says use 1 over sine. Right? Okay, so if that's true, then that must also be true, right? Yes? Okay, so there's 2 of them. Guess how many we get? We get 6 of them, right? So these are called, because we did that flipping thing, these are called your reciprocal identities. I will show you them all. So there's our first one. Cosecant theta is equal to 1 over sine theta. Got it? And then you could imagine I could have done the same thing with, well, I did that with sine. I could do the same thing with,
Tangent, and secant and
yeah, I could do the same thing with cosine, right? Just flip the fraction around between secant, and I would get back to, hey, that's the same as this, which is the same as cosine. So therefore I could get that statement as well too. Use the same logic, and that one. All right, so let's write that one down. Too fast, okay? And then the last one, of course, is cotangent is equal to, and I'm not going to prove it, but there's the proof, right? All right. Now here's the deal. If you open up to your back of your book, it shows these 3, but guess how many there actually are?
6.
There's 6. I don't know why our book chooses to leave off sine, cosine, and tangent.
Because you already have buttons.
Yeah, but you're thinking about this in terms of graphing. This is in terms of algebraic manipulation, right? So in terms of graphing, yeah, this is so what I want you to do, maybe in the margin somewhere, is to put those other 3, because we are going to use these. But if you open up, you can open up the back of your book and look. It's one of the first ones listed.
That's 6. We're good.
I said about 11 or 14, I forget. We'll count. I taught this already once today, and I meant to count, and I forgot to count. Thank you. Okay, these are called the reciprocal identities. Everybody okay? The only reason I put a red thing around this because it just matches what's in the back of your book. You're not going to see these other 3 written, but they're an obvious addition to the original 3. Okay, so we're up to 24, right? 18 original ones, 6 more, that's 24. Okay. All right, so think about this. True? All right. Tangent equal opposite over adjacent, right? I drew a big circle, but I only drew part of a circle. Everybody see what I did? All right. I'm going to put the coordinate plane smack dab in the center, yes? Maybe it's a unit circle, maybe it's not really important right here, but I have a circle whose centered is on the coordinate plane. I'm going to pick a point on the circle, and I'm going to do what I always do, which is draw a triangle. Remember, when you do this, you must draw it from the point to the origin, and then you never go to the y-axis. You only go to the x-axis. Hey, remember doing this?
Yeah.
And that is your theta. Okay?
I have a calculator for this.
All right. Remember, in terms of what I just wrote there for that trig identity, that's your opposite side, that's your adjacent side. But we have learned that this distance is actually, okay, but ignore, I never said it was unit circle or not the unit circle. We've learned this distance right here is, say it again, this is x and this is y, right? Yes, that's one we already have. But wait a minute, I got another trig function that tells me something about y. What's that other trig function that says something about y? Say again.
Sine theta.
Sine theta is equal to y, right? But the but part. And then cosine theta is equal to x. So therefore, I can do a substitution. Therefore, I now know that tan theta is actually equal to sine over cosine. I just skipped the word theta there. So there's a new one. And therefore, cotangent will be equal to, yeah, there's two more, right? These ones, because it's a fraction, these ones are going to be called, we didn't flip anything. We didn't do a bigger word for fraction or a fancier word for fraction. Anybody? These are called the quotient identities.
Fractional sum.
Yeah, that would work. Okay, we're up to 8 plus 8 plus 18 is 26. So here's a 26 identity.
There's only 2 in that box?
Only 2. There's only 2 because we already have, if you were to do the same trick about what's it equal to y, right? So we know that sine is equal to y. So it's sitting right here, right? This is that one for down here. So we already have that one written. These are used, the quotient ones are used often, frequently. Tangent pops up a lot of times. So any trig identity that has the word tangent in it, you're going to use that one quite frequently. Turns out. It's because it's opposite over adjacent. Whenever you're doing a triangle, those are the sides, the length and the width of something. Everybody okay? All right. There are many more, right? So what are these good for? I'll show you what we're going to do tonight for homework. We're going to be simplifying things. So it says, find the remaining basic trig values. Whenever it says basic trig values, they're talking about what are the basic trig values?
Cosecant, secant, cotangent.
Those are the 6 basic functions. So how many did they give me? So how many are left? 4. So that's what they're asking you to do. They're saying find the remaining basic ones. Well, if they gave me sine and cosine, then I'm missing tangent, cotangent, cosecant, secant. Okay? This is much more easy than it appears. It says, what's tan theta? Well, what is tan theta according to our identities that you just wrote down? What is tan theta? Sine over cosine. If only we know sine and cosine, and guess what? They did. They gave us sine and cosine. So what's sine? What's cosine? Okay, well, it's that big hot mess. So what do? Copy dot flip. Hopefully something cancels. 5s cancels. Root 5s cancel. And you're simply left with wrong. 1 over 2. So 1/2. Yay! That wasn't too bad. But once again, why am I doing this? That's the part that's like, okay, if you like math, then that's fun. But if you're like, well, it has to have a purpose, this doesn't really have a purpose. It will when we get to calculus. Okay, you want to do the next one the easy way or the hard way? Well, you just did tangent.
Oh, then it's just
Flip.
cosine.
So then the answer is,
2.
yay, you are smart.
And then just flip sine.
Well, no, the signs would always be the same. Signs would always be the same. Well, what do you mean by sine?
For cosecant.
I thought you were about tangent, cotangent, right?
No,
Signs, typically use what sign when it means positive, negative.
oh, no, sin.
All right. Oh, you were using SINES. I didn't even catch that. Okay, so what are we going to use for cosecant?
Over sign.
1 over sine, right? But we know what sine is. Sine is,
Root 5 over 5.
okay. You happy with that answer?
No.
So what do we got to do? Okay, I did the copy dot flip for you. You happy with that answer?
No.
What do we got to do?
It's root 5, yeah.
Okay, can you do that in your head?
Yeah, it's root 5.
Why is it root 5?
Because the 5s cancel out.
Because the 5s would cancel out, right? And you would just left with root 5. Well, we can't do any nifty trick to change cosecant into secant. We actually got to do the work. But secant is,
Secant is just 1 for cosine.
so I could do the cosine and flip it immediately if I wanted to. If I wanted to do it the long way, then I would write it as 1 over that. But I did it the easy way. I just took whatever cosine was and I flipped it. But.
Yeah, root 5.
Okay, so top and bottom by root 5. No, you can't multiply and cancel at the same time.
It's 5.
Oh, 5 root.
5 root 5 over 10, which will reduce to,
2 root 5.
you put the 2 in the wrong place.
No, root 5 over 2.
Root 5 over 2. Because that would be a half, 5 and 10, right? So 2's on the bottom. Too quick or okay? All right. I'm not changing it. Point being is like there's nothing challenging here as long as you remember what trig function to use. Now, I forgot to count already of what we're up to, but we got a lot of trig identities. So knowing the right trig identity is the key to getting these done. And then understanding some, I don't know, inner details about, hey, if you got tangent, you actually do have cotangent or vice versa. That sped up the process a little bit. Do another one or you got it? You sure?
Another one.
Mish says do another one. Tell Tyler to stop making faces. Tell him to go away.
Well, there's more than one person outside the door. Just like.
All right. Okay, so one more. Ish. We need the 5 or the 4 that are missing. Which 4 are we missing?
Oh, 10.
Wow.
Okay, thank you.
Cosecant.
Or maybe you have secret powers that you didn't know.
Sounded like an old grandma.
Get it?
Oh, help my mom.
Come on. All right, so what are we doing?
Sine. Cosine for tangent.
Okay, so sine over cosine, so that would be
1/2.
1/2 over. Can you do that copy dot flip in your head?
-5/8.
-5/8. Well done. Right? If you can't, well, just do the copy dot flip. Okay, so if that's tangent, cotangent would be,
Negative.
well, that was quickly done. And you do have to work with cosecant and secant. The hardest thing for cosecant and secant is always remember what is it, the sine or the cosine. So cosecant goes with sine, so take sine and flip it. That was easy. And take secant goes with, so flip it. Well, that was quickly done. All right, so that's just kind of a taste of something you can do with some of the trig identities. I'll try to give you a little taste as we go along each time. Are we okay? All right. So not too bad. More trig identities? Said no one ever, except for Seth. All right, so there's your pig if you're getting overwhelmed.
I feel bad for that pig because every time I look at a pig now, I go, oh, I dissected one of those in 9th grade.
Right. It was awful.
Sounds awful. Like you see an innocent little piggy and you're like, hey, I dissected your friend. Like,
Okay, they were never alive.
They were dead.
Yeah, there's some ethical, moral things going on there, but they served a greater good. If they gave you more respect for life, then they gave you a greater good. All right.
They did.
Fetal pigs.
Fetal means not born.
Oh.
Right.
They were never, the mother died.
What-
That's how they heard it.
What's going on? Hey, I gotta teach, so you guys can't make a disturbance.
So they were
Right.
gonna be alive.
AJ, straight in. Heather, come on.
All right. Hey, do you remember this formula? It always pops up. Do you remember this formula? It always pops up. Does anybody remember it?
RK. Circle.
It's a circle formula.
What is the circle formula?
Square.
No, that's area of the circle.
Nope.
Nope.
H minus something.
At least that's on the path to the right answer.
Well, R squared is equal to, I don't know.
R squared is equal to,
Wait. Give me
Eight.
1 second. 1 second.
X minus H,
How am I
Y
seeing?
minus K.
you're better, you're really almost there.
Y minus
Square, there's a
H.
square
X.
somewhere.
There's a square on there.
There's a square somewhere.
All right. So this formula always tends to pop up, and it's one of those ones that like it's useful because it's a circle. Okay, cool. So that is true, but what do we know about the unit circle?
It's a circle.
Of radius. So I could consider the unit circle, so I can make the R1, and why did I put 0, 0?
That's the origin.
Because at the origin, it's 0, 0 for X and Y. And H and K is where the circle is centered at. So if I put 0, 0, what are we left with? Okay, yes? Right, you everybody with me? Okay, I'm gonna just do a little bit of rearranging the decks on the Titanic here. I'm just gonna move the X squared and the Y squared around, right? I'm just rewrite. Addition is commutative, I can move them around all I want. Okay, cool. You ever seen the letter Y before?
Yeah, all the time.
No.
Why?
Okay, where have you seen it before?
On a map field.
It's a trig identity.
Gross. Did you not get my dad joke, Mr. C?
Y is sine, right? For the unit, on a unit circle. I made the radius 1, so I'm still on the unit circle. We know that sine of theta is equal to Y. We also know that, stay with me, stay with me. We also know that,
One over Y.
Cosine is it.
cosine is X. I'm done with Y, I'm on the X now. Okay, cool. So I got a Y and X, and guess what I have in the formula?
Y and X.
A Y and an X, so I could,
Sine squared.
okay, you ready for this? Yeah, sine squared plus cosine squared, right, theta. Mathematicians are, we are super lazy, right? There are two ways to write sine squared, right? I have no idea where my pen went. I had a pen. No. So if I had sine theta and I wanted to square it, well, one thing I could do is put parentheses around it and put square. Right? That would be squared. If I put a square next to there, this implies what? That theta is being squared. I'm not squaring theta, the angle, I'm squaring the sine function. So parentheses, but if I draw parentheses, how many things I gotta draw? 2 parentheses and a square, that's 3 things. So mathematicians being lazy, we just put the 2 right here. So if the 2 is next to the word sine, it means the sine is being squared. If the 2 is next to theta, it means theta is being squared. So that's your explanation of why it looks like that. Okay? So it's not theta being squared, it's sine squared being theta. Hey, if I go back to the original formula, this looks an awful lot like the Pythagorean theorem, right? If instead of writing 1, I write 1 squared, then it says something squared plus another thing squared equals another thing squared. Pythagorean theorem. That's why we call this one
Pythagorean squared.
we call this one the Pythagorean identity, right? So these are called the Pythagorean identities, implying there's more. So here's your first one, and it's the most widely one that's used. If you ever see the number 1, instead of writing 1, you can write sine squared plus cosine squared. If you ever see sine squared plus cosine squared, you can write 1. It's a pretty convenient one to use. This is called the Pythagorean identity. I just did the math in my head. It is 11, not 14 identities today. Because there's going to be 3 of these. No, I said it was either 11 or 14. So 11 plus 18 is 29. We're going to have 29 identities by the time we finish today. Well, and on the good thing about it, if we're already up to 29, that means there's only 21 left.
Oh, so cool.
That's right.
And that's a rough number. It's around 50 that we'll learn. Okay. All right.
Wait. Is this the last, hold on,
I'm gonna have 3 of these.
no, is this the last lesson of the chapter?
No, we're only in the middle.
Why would we start it?
I can't, well, we can't just sit around in hammocks and sleep all day.
Yes, we can.
But we can, but we're not going to.
We can.
All right. So now I'm gonna do, stay with me. Now I'm gonna do a little bit of algebra. Okay? I'm just gonna do a little bit of algebra. Yes, you are.
By the time we get back from.
That's why it's on a resource card. Okay. For some strange reason, I would never have thought of this. They decided to take this entire equation and divide everything by cosine squared.
Why?
And you'll see why here in a second.
Get rid of cosine force.
No, somebody decided, let's divide everything by cosine squared. So they did that. Now let's see what happens. Do you recognize the first thing? That's tan squared. Do you recognize the second thing? It turns into, and do you recognize the last thing?
It's
Secant.
It's secant.
I got secant and tan. Which one is it?
It's secant.
It's secant. So that turns into 1. The first one turns into tan, and yes, you did see it. And the last one turns into secant. So here's our next Pythagorean, and this came from Pythagorean identity, which is why this one's also a Pythagorean identity. Okay, so there's your second to the last. Do I need to print out the picture of the pig for you?
Yes.
Actually,
Yeah, I
all
would
of
like
that
that. We
being
all have
hidden
the
up on
pig.
my
We
fridge.
should name the pig. I want the piggy.
Gotta name it, so.
Petunia.
You should
Absolutely.
put it in the back.
Me.
It does have a daisy in its mouth, so daisy.
Mr. C,
Daisy's
you should
cute.
print out like a color picture of it and put it on the board.
Bacon.
All right. Hey, somebody decided to take this whole thing and divide it by cosine squared.
Sign.
If we did it by sine squared, I'm not going to prove it to you, right?
I don't know.
But if we did it by sine squared, we get to the last one. If you'd like to do the proof all by yourself, it's done the same way.
I agree with.
All right. So there are all the identities, the new ones for today. So there are 11 of them. 6 for the first one, plus 2, 8, plus 3 is 11. Okay, everybody good? All right, so we'll just do some examples. All right, this is what homework looks like. Now, the issue with this is that there's no directions on how to do this. It's your ability to look at what you've got and try to manipulate it with trig identities and try to get to an easier answer than what's given. That's not very good instructions. Like, just mess with it and see what happens. And that's kind of what the instructions are. So for me, those are 2 problems there. I look at it and I try to think about trig identities at the same time. So I'm looking at tangent and I'm looking at this fraction and trying to see if it matches some trig identity I know. Anybody? What do you got? Sine over cosine is tangent. So I could rewrite this fraction as just tan 20, right? Because of that identity right there.
What if that different?
Yeah, what if that-
Well, with it different numbers, then this would not work. I mean, I could rewrite it as that, but I'd have tan 20, tan 30, right? But in this case, I literally have tan 20, tan 20.
No, what if it was sine 20 over cosine 30? Then we
Yeah.
just leave it.
Well, I'll answer that question just a second after I finish the question here.
Is it tan 230?
Well, it literally says tan 20 minus tan
That's
20.
Zero.
So it's 0. Now, to answer your question, what if it had said sine 20 over sine 30? We need a new identity for that one. So if the numbers are not the same, well, then you're out of luck until we learn a new identity. And we will have an identity for that, just not today. You'll notice in homework that all of your thetas are exactly the same tonight for homework until they're not. I'll show you a sneaky one. All right. Second one, what do you notice? Okay, so what else do you notice?
Okay, the second one is cosine.
Oh, the second one's cosine squared. So I will write that as cosine squared. Okay. So anybody, it's not yellow. Anybody notice anything? Why would it be equal to 1? And doesn't it say sine squared plus cosine squared? So therefore, it equals 1. Yay, good job. Yeah, that was good. You like the Grinch, except it's your brain?
Yeah.
Do the theta values have to be?
They have to be the same. They have to be the same. That was Ish's question.
Well, that was her question.
Okay. So,
The same question, okay?
all right, cool.
Different.
All right.
Different.
That one's a little bit more challenging, but group effort, we figured that one out pretty quickly.
You can just go.
More?
Yes.
Okay. All right. I got 2 problems. First one. Anybody recognize anything?
Just turn it into.
Eight is the same. Say again. She says turn cosecant into 1 over sine. Now, how did she know to do that? How did she know? Why did she mess with cosecant and not sine?
Because I'm squares.
The answer is, well, you kind of also think about what you're given. And if you turn this into 1 over sine, then the signs would cancel. And you'd be left with just uno. All right, so we'll call this the Ishibi,
It should be-
Abby-ish.
I like it should be better.
This is the Ishibi question right here.
Okay.
The Ishibi question is, well, what happens if theta is not the same? What did I tell you?
Because we can't do
You
anything.
can't do anything until I teach you a new identity, yet it's a question for today. So there must be a sneaky answer to this one.
Divided by
You
10.
can't. The theta is on the inside.
Divide theta by 10.
Well, you could, then the theta still would not be the same. So are these numbers the same? Yes or no?
No.
No, clearly those are not equal, or wait a minute, I said they're equal. I literally put an equal sign. Are they equal? Or is it a math mistake?
Mistake.
Where is 400 degrees?
What's on the?
Where is 400 degrees? Think it through. Where's 400 degrees?
At 40, 360 minus 40
Plus.
plus 40 is 400.
They're the same thing, right? So they're going to throw a sneaky one on you, and they're going to put 2 different numbers. Don't assume that they're the same. Make sure they're the same. But yeah, 40 degrees is 400 degrees. It's just you've gone around the circle once and gone 40 more degrees.
So it doesn't matter.
Doesn't matter, because remember, we always get the same answer. We call it the reference angle. If you go around twice, it's that skateboard analogy, right? You flip the skateboard 360 degrees, the skateboard's facing in the same direction. Okay, so what are we going to do now? Cosine secant. Okay. Therefore, yay. Don't assume that all the answers are 1s or 0s, but most of them are. Because these are just math teacher problems right here. Does that make sense? Okay. All right. Here's some realities to leave you before Christmas break. Okay. It looks easy. It's like these 2 things multiply together. It should be easy. And then all of a sudden you're stuck there all by yourself. You don't know what to do. Typically, they're a little bit more challenging, right? Most of the time, there's never an obvious solution. It's like, well, I don't know if this is the solution. Let me change tangent into sine over cosine. Let's see what happens. So there's usually never an obvious path to the solution. You just go down a path and see if it leads you to something, right? Typically, when you're doing these initial trig identities, they're all math teacher answers, like 1s and 0s and 2s and 3s. They're generally pretty straightforward. In real life, it's not the case. It's always easy when somebody shows you the answer. right? Oh, just change this to 1 over cosine or something like, oh, why didn't I see that? So this one right here, it's always easy when somebody shows you how it's done. Don't let that become the tier thing, right? It's just practice. The more of these to do, the easier they become. When you first start doing them, they can be a little bit challenging. So no tiers allowed yet for these, right? It's always challenging when you do them by yourselves, right? You do them with a couple other people. Seth said, "Oh, look at that," and everybody goes, "Oh, yeah." But remember, when you're doing it by yourself, you're the one that has to come up with that little nugget, right? And a lot of times it's hard to do, right? If you notice on that sheet, the teacher wrote right here, try something. Even if it's the wrong thing, try something. Like, I don't know, maybe I should change tangent to sine over cosine. Let's see what happens. That's the try something part. We'll talk about all these little hints and trying things as we move into these trig identities. And if not, there's always a pig with a flower.
I just feel bad for that pig I dissected.
It was never alive.
Well, it was alive.
Well, it had no chance of surviving.
It just was never born.
Yeah,
But it was alive.
Well, it was already dead when they had it.
Wait, are we done?
Yeah, that seems about enough for today.
Can
They
you go
didn't
back
kill
to
it.
I
the?
know they didn't kill it. I just start laughing when I see a pig now.
You also dissected a cat.
You know this is all being recorded for posterity.
Oh.
Because Evelyn needed to record. All right, Evelyn, that's it for the day.
Five, 2, 5, that's it, 5.